Good day, viewers. I remain your favorite tutor. Okay, today we'll be talking about projectile. Projectile is an object launched or released into the air and allowed to move under the influence of gravity. We have examples like a stone released from a catapult, a stone thrown vertically into the air, or a ball rebounding from the wall, and also a bullet released from a gun. There are numerous examples of projectile in as much as the object or body is allowed to move under the influence of gravity. Alright, I'm going to bring out the equation necessary for what to tackle problems under projectile. But we are going to consider two cases. The first one is going to be an object being released or projected horizontally from a cliff. And the second one is an object being projected at an angle of inclination, either to the vertical or horizontal. Okay, we take the first one. If this is the horizontal height, which is h, that is an object being projected horizontally. Is the what? The velocity projected horizontally. This is the point of landing. Alright, this is the final velocity. Let me put it this way. This is the final velocity. Okay. While the horizontal distance is known as the word range. Alright, this is the object. It moves until it hits the ground. The final velocity. Okay, an object being projected horizontally from what? A height. You can see the object is observing what? A parabolic movement. The kind of movement we call the word a parabolic movement. Under the influence of what? Gravity. You see the motion of this object. It has two independent motion. Two independent motion. That is what? The vertical motion. Let's say V subscript. The vertical motion and the what? The horizontal motion. Now, for the vertical, there are certain things we need to understand right here. Experiment has shown that the time it takes for this body or this object to move through this parabolic path from point of release to point of landing is equal to the time it takes for the body to fall freely from this height to the ground. And is also equal to the time it takes to cover the horizontal range. Yeah, it means that if, let us assume that this is the body. If I drop this from this height freely before under the influence of gravity, it's the same time it's going to take if this object is being projected with a what? A velocity. Right here, the initial velocity is what? 0 to the ground. But if we project it with a velocity and allow it to move under the influence of gravity, the time is going to take from point of release to the point of landing is the same time it's going to take if I release it from this height to the ground. The same time is going to take to cover the distance. And also the same time is going to take to cover what? The horizontal distance, which is the what? The range. So we are going to consider what? Motion under what? Gravity. That is, we consider the two independent motion, the word vertical motion and the horizontal motion. And the vertical motion, we are talking about what? Motion under what? The influence of what? Gravity. And we have discussed this in some of our previous videos when we discussed about what? Motion. You can go to my YouTube channel, favorite tutor, and get details about motion under what? Gravity. And motion under gravity, the equation, let me put it right here. Okay, let me drop it here. The equation we are looking at is going to be V equals to what? U plus GT. We are using what, the positive sign, because it's going down due to what? Gravity. If it's going up, that is against gravity, it's going to be what? Acceleration to gravity will be negative. So the other one is what? H equals to UT plus 1 over 2 GT what? Square. Okay, then the last one is V square equals to U square plus 2GH. Now this is the what? The vertical motion. So we just put it here. Y, vertical motion, vertical motion. Yes, vertical motion. Okay, but in this case, for something to fall freely under the influence of gravity, it means that what? U subscript y is equals to 0. That is the initial velocity. So we just do what? Substitute to what? 0. So in this case, that is Vy is equals to what? Gt. And also in this case, we are going to have that what? H. Everything here is what? 0 is equals to what? 1 over 2 gt squared. Then of course, this other part, this last one, this is what? 0. We are going to have that what? B squared is equals to what? 2gh. Alright, let me put this formula here. Let me put it right here. We'll make use of it. Gt, then h is equals to what? 1 over 2g squared, then b subscript y squared is equals to 2gh. Alright, this is the what? The vertical what? Motion. For this what? For this, in this case. Then also for horizontal. For horizontal, that is the range. The horizontal distance. The range. So we'll look at this equation, which is what? Instead of using h, we are using this one. That's the horizontal distance. We use what? Arrow, which is what? ut plus 1 over 2 at squared. You can say that we are using what? A, because this is what? Rectilinear motion. Motion on a what? On a straight line. It's not due to what? Gravity. So we are using A instead of what? G. Now, if this is the case, in this horizontal what? Motion, there is no acceleration. There is no acceleration. We believe, experiments have shown that the velocity at the horizontal velocity does not change. It does not change from point of release to point of what? Landing. The horizontal velocity does not change. And if the horizontal velocity or the horizontal speed does not change, it means that there is no acceleration. That acceleration is equal to what? 0. Remember Newton's first law of motion that states that the body will remain at rest, or what? Uniform motion. Uniform motion is the same thing as the body being at what? Rest. So the body observes what? A uniform, a constant speed throughout. That is the horizontal what? Motion. So therefore, acceleration right here becomes what? 0. Then arrow is what? That is the horizontal, which is what we use x. Then what? T. So let us put it here, because everything right here is what? 0. So becomes what? X what? T. Okay. Now for this case, these are the equations we use when a body is being projected from a what? From a height. Projected horizontally from a what? A height. Okay, let's discuss the other one. The other case, case 2. That is when a body is projected at an angle of inclination. When a body is projected at an angle of what? Inclination, either to the what? Horizontal or to the vertical. Now, let's look at it this way. This is the initial velocity. This is the velocity. And the body is being projected. Wow, I hope this thing is beautiful. No, let me take this part again, this parabolic part. Let me do it again. Wow, it's good this way. It's good this way. This is what? Final velocity. And of course, we have the what? Vertical y. Then the horizontal remain what? U does not change. The x. Then this is the maximum height. We call it h. This is the maximum height. Then this is the word range. The body is being projected at an angle of what? Inclination to the horizontal. Consider this horizontal. That is what? Theta. Okay, this is the angle, this is the resultant. This speed or velocity, the resultant, we can resolve it into what? The vertical, that is uy, and also the what? Horizontal, which is what? Ux. Can resolve this one, this velocity or speed into the vertical and what? Horizontal to get the what? Vertical speed or horizontal what? Speed, as the case may be. Okay, all right. The first equation we are going to look at here is the time it takes to move this part to the what? Maximum height. The time it takes to move this part to the what? To the maximum height. And it's very easy to get the time it takes. Okay, I'm going to clean this part. Very easy to get it. We just use what? Equation of motion to get the what? The time it takes, which is what? V. But before we do this, we also need to put in mind that you see this part. This is the resultant speed. Something just, okay, this is the resultant speed. Now, we can resolve this into what? The vertical and horizontal. To resolve it, it means that what? U subscript x is equals to what? That is the horizontal part is what? U cos theta. And U subscript y is equals to what? U sine theta. This is what? Vertical. This is what? The vertical. Why this is what? The horizontal. Sorry, this is what? The horizontal. Why this is what? Vertical. If we resolve this speed. Okay, since we are using equation of motion to get the what? The time it takes to go to what? Maximum height. Okay, from this, that is V subscript y equals to what? U subscript y. We are using minus what? GT, because against gravity, going against gravity. So we are using what? Minus. And then we know that to get to maximum height, it has exhausted all its speed. It can no longer go further. So at this maximum height, there is no speed. So velocity, final velocity is what? 0. Final velocity is 0. That means V subscript y is equals to what? Minus gt. I take this, I just swap it, so I have that what? Gt is equals to what? Gt, this minus gt, we are looking for what? No, I think I make a little tiny mistakes. Okay, no. The final velocity is what? Equals to 0. So therefore, we have that 0. This is the final velocity, the initial velocity, is equals to what? U y minus what? Gt. Take this way, we have that what? Gt is equals to what? Uy. So therefore, T is equals to what? U subscript y over G. Now, this U subscript y is the what? Vertical component of the what? The speed. Vertical component of the speed is what? U sine theta. So this becomes what? U sine theta over what? G. That's the time it takes to get to what? Maximum height. Now, what is the time it's going to take to go down? the time it's going to take to go down is the same time it takes to go up. So when we talk about what? Total time of flight, that is from point of release to point of landing. Total time of flight from point of release, we use capital letter T, is equal to what? 2T. This guy, time it takes to do what? To get to maximum height. At the same time it's going to take to get to what? Point of what? Landing. So therefore, total time of flight is equal to what? 2, what is T? 2 what? 2u sine what? Theta over what? G. Now this is what? Time of what? Flight. That is the total time it takes from point of release to what? Point of landing. You drop it here. T is equal to what? 2u sine theta over G. Time of flight. Okay, we are going to consider another equation. And this one is maximum height. Maximum height. Alright, this is maximum height. This maximum height. We are going to use b square is equal to what? U square minus 2gh. Maximum height. Time it takes to get to maximum height. Now to get to maximum, this maximum, not time it takes, we are looking for the equation for what? The maximum height. Okay, at maximum height, v is equal to what? 0 at maximum height. So therefore 0 is equal, this is the final velocity, is equal to what? Square y minus 2gh. So take it this way, this is what? 2gh equals to what? Yeah. So therefore, we know that this is the what? The vertical component of the what? Speed. Vertical component of the speed is equal to what? U sine theta. So we just include it. That's what? H is equal to what? U sine theta power of 2 all over what? 2g. Okay, just simplify it. We have that H is equal to what? U square sine 2 theta over 2g. Now this is what? Maximum height. Alright, let's put it right here. That maximum height is equal to u square sine square theta over 2g. And the u square sine square theta over what? 2g. Maximum height. Okay. The third one is going to be the what? The range. That is the horizontal distance. To get the range. And to get the range is very, very simple. To get the what? The range. Okay. For this range, we know that in the range, there is no horizontal, there is no acceleration. So it's the same thing right here. Just this, that the range is equal to what? Use subscript x, then what? Instead of using this small letter t, we use capital letter T, because that's the what? Like I said, the time it takes to observe this parabolic movement is the same time it takes to cover the what? The range, the horizontal distance. So we are using what? The time of flight. So that's going to be the range, is going to be, this is the horizontal component, which is u cos theta. Let me put this in brackets. Time of flight, this time of flight, 2u sine theta over g. Okay, everything here is going to multiply everything here. So therefore, this is going to be what? U, that is what? U square. This is the same thing as what? 2 sine theta cos theta over g. 2 sine theta cos theta over what? G. But you need to know that in trigonometry, this 2 sine theta cos theta is the same thing as what? Sine 2 theta. It's the same thing. So we just put it right here. That the range is equal to what? U square sine 2 theta over G. So this is the range. We put it right here. Range is equal to what? U square sine 2 theta over G. Okay, I think these are the equations we need to know to tackle questions on projectiles. On projectile. Okay, there's still one more. Yeah, this one is equation of the trajectory. Equation of the trajectory. That is what the motion of the body. So we'll just look at. Okay, let me just do it. Equation of the trajectory. For equation of the trajectory, we know that the horizontal, we use x for horizontal, we use y for vertical. For horizontal is what? Ut cos theta. Ut cos theta. Because this horizontal component is what? This horizontal component is what? U cos theta. Then what? T. T. Then for vertical, we are looking at say U. That is Ut sine theta minus 1 over 2 gt square. Okay, yeah. Ut sine theta minus 1 over 2 gt what? Square. That is from this horizontal component. This horizontal component, if I make t subject formula, t is going to be what? X over what? U cos theta. X over U cos theta. Now, if I, let me call this equation 1, I call this equation 2. Now, if I put this into equation 2, that is where you see t, you put this. Then y is equal to what? U bracket x over U cos theta bracket then what? Sine theta minus 1 over 2 g bracket x over U cos theta. Then what? Square. Okay, we just simplify it. From there we get what? Equation of the trajectory. Okay, so from here we know that y is equals to, okay, from here we can say that u take out u, that is what? X sine theta over what? Cos theta minus, this is what? G over 2, then what? We have x raised to the power of 2 all over u square cos square theta. Okay, so this becomes y is equals to sine over cos is what? Tan. That is x tan what? Theta minus gx square over what? 2u square cos square theta. Now this is what? Equation of the what? Trajectory. Okay, we have come to the end of this what? Episode. In our next class, we are going to take what? Questions. SSE questions, UTME questions concerning this what? This topic. Thank you very much and God bless you.